On numbers 8, 9, 10, 11, 12, we're going to use a method on factoring called factoring by grouping, okay? And why is it called by grouping? Because we take this huge polynomial and we make two groups of it. It's kind of like we split it right in half. You have this half and you have this half. So let me just walk you through, even though you could look at your notes to look at it step by step. But let me walk you through right here. What I'm going to do is focus on number 8 here. And I'm going to first make two groups, all right? I'm going to have the 4x to the third minus 8x squared. Then I'm going to leave some space, and then I'm going to put the plus 3x minus 6, okay? So I first separated into two groups. Now I take a look at the first group, okay? Is there anything that I could pull out from the first group? Yeah, there's the number 4. And 8, that means you can pull out a multiple of 4. Not only that, you could also pull out x's. You have an x to the third and you have an x squared. So the GCF that you could pull out from that first group would be 4x squared. Okay? And what would be left if you pulled out a 4x squared? If you pulled out a 4x squared, what would be left would be just an x. And in the second term, if you pulled out a 4x squared from here, well, you'd have a minus 2. No more x's or x squares, right? So let's do the same to the second group. What is in common in the second group? Well, you could pull out a positive 3, and I'm going to put a positive in front of the 3. And if I pull out a positive 3, what's going to be left? There's going to be an x minus 2. So, once again, we split it into two groups. You factored from the first group. You factored from the second group, right? First group factored. Second group factored. And what do you do now? You take a step back and you realize there's something in common in group 1 and group 2. And I left them both in red. What's in common in the first group and the second group? There's a binomial in common in both, the x minus 2 and the x minus 2. So what I'm going to do is pull out an x minus 2, and what will I have left in the whole thing? Now this is what you got to do. You got to pretend that this is one giant thing, which it really is, and we pulled out this x minus 2, pulled out that x minus 2, and put it out here in the front. So what's going to be left on the first group if you pulled this out? It's no longer there, just the 4x squared. Let me write that, 4x squared. Now, what's going to be left if we pulled out the x minus 2 and put it out here? What's going to be left? This is no longer there if you pull it out. It's just a plus 3. So let me put plus 3. Now, obviously, the parentheses are too big. They don't look that nice. So let's rewrite it with the right size parenthesis. And that, my friends, is factoring by grouping. Let's try one more, shall we? Okay, I think I'm going to go for number 12. Sure, why not? Number 12. Okay, so we're going to separate it into two groups. That's what we're going to do first. And we're going to write the first group. There it is. And the second group, I'm just going to leave some space. So what we're going to do is look at the first group and pull out what's in common. And that would be a 4x squared. And what would be left if I pulled out a 4x squared? Well, there would be an x and a minus 2. Kind of looks like the other problem. Anyway, how about the second group? All right, what about the second group? Well, there's nothing in common. There's nothing to pull out, right? Now, this is a special problem because you can't pull out anything from the x. There's nothing in common with the x and with the 2. So you could pull out a 1, but that's not going to help you. And if you think about it, what you want to ultimately have is the same exact binomial right here, okay? So if we just put this in here, it's not going to be the same exact binomial. As a matter of fact, this is a positive x, and this one's a negative x. This is a negative 2, and this one's a positive 2. So we want this binomial, but over here it's opposite. So what I'm going to do is pull out a negative 1. Let me change that to blue. But if I do pull out a negative 1, what that's going to do is leave me a positive x and a minus 2. Okay? So now, after separating it into two groups, after factoring from the first group, factoring from the second group, now you take a step back and you look at what's in common in the whole thing. Again, it's kind of like if you pretended there's parentheses around the whole thing. What's in common in the first group and the second group? There's the binomial x minus 2. Okay, sorry, I'm writing all over these guys. Let's ignore those for a little while. What's going to be left on the inside if I pull out an x minus 2 and an x minus 2? What's going to be left? There's going to be a 4x squared minus 1. That's what's going to be left. Now, of course, look at those parentheses. They look huge, right? Huge parentheses. I just exaggerate those parentheses so you could clearly see that this is no longer there and that just comes down. This is no longer there and this just comes down. So let's rewrite that the expression, but with the normal size parentheses. And there we go. Now most people think, yeah, we're done. Yeah, we factored by grouping, right? We split it into two groups. We factored from the first group, factored from the second group, and then we pulled out what was in common in both groups, and we have this. Beautiful. But always check the inside of the parentheses and see if you could continue factoring. So right here, x minus 2, there's nothing else to do. But over here, 4x squared minus 1, that is a difference of two perfect squared terms, right? A difference of two squared terms. So we will be able to factor it even further. If you take the square root of 4x squared, that's 2x. If you take the square root of 1, that's just 1. And of course, this one's a plus, and over here you have a minus, because that's the only way it'll end up as a binomial if the signs are opposite. Let's not forget about the x minus 2 that's out here in the front. So ladies and gentlemen, that is the final factored form, completely factored form of number 12.